Hey guys, welcome to Courage. This is Saransh, and in this video we are going to find the number of possible permutations and combinations. First, let us understand permutations. Permutation is each of several possible ways in which a set or number of things can be ordered or arranged. In mathematics, the action of changing an arrangement of a set of items. Let us understand this by an example. Suppose you have to find in how many ways can we award gold, silver and bronze among 8 contestants. Let us assume we have students namely A, B, C, D up to H. Now we have 8 choices for giving the gold, and suppose we give it to A. Now since A cannot be given all the prizes, we have 7 choices left to choose from for the silver. Now let us assume that we give it to B. So similarly, now we will be left with 6 choices for choosing for bronze. Hence, we have 8 into 7 into 6, that is 336 possible orders it can have. The mathematical formula for this is NPR, which is equals to factorial n upon factorial n minus r, where the n is the total number of objects where we are finding the possible permutations of r objects, and the exclamation mark stands for factorial, that is the product of all positive integers less than or equal to the number itself. For instance, 4 factorial is written as 4 and exclamation mark and means 1 into 2 into 3 into 4, which equals to 24. Now let us understand a mathematical example. Suppose we have to find 6p3, then n is equals to 6 and r equals to 3. So in the numerator we will have n factorial, that is 6 factorial, and in the denominator we will have n minus r factorial, that is 6 minus 3 factorial, which equals to 3 factorial. Now if we expand both of these, then we can easily cancel out 3 into 2 into 1 from the numerator as well as the denominator, leaving us with 6 into 5 into 4, which is equals to 120, which is our answer. The following program I have done using functions. We have taken 2 functions, one for finding the factorial and a function permutation to apply the formula for permutation. Now we will take the value of n and r from the user and call the function permutation. Now you will see that this function returns an int value, so we will need to store that value in another variable here, which is npr. Now the value entered will be specified in the function parameters, and the formula now would be used to find the permutation. Now here you will see that the function itself calls another function factorial twice, one for the numerator n and the other for the denominator n minus r. Now in the factorial function, as you can see, the variable c and result have been initialized to 1, and the loop goes on until c reaches n, that is c is less than equals to n, and result into c is being stored in result continuously until the loop ends to find the factorial and result is returned. Now let us take a quick look at the whole program. 3 integer variables n, r and npr are declared. User is asked to enter the value of n and r. User enters the value of n and r using scanf. Permutation function is being called and the value of n and r are used in the function arguments. The result of the factorial of numerator and denominator is stored in the variable result. The statement will in turn call the factorial function, which will find the factorial of the numerator and denominator, and the value will be returned to the function permutation, where both the values will be stored in the variable result and result will be returned. The value returned will be stored in the variable npr, and the value of npr will be printed using printf. Now let us get straight into combinations. A selection of a given number of elements from a larger number without regard to their arrangement. Unlike permutations, it takes the sets with a different order but same value as 1. Let us understand this through an example. Given 3 fruits, say an apple, an orange and a pear. There are three combinations of 2 that can be drawn from this set: an apple and a pear, an apple and an orange, or a pear and an orange. Here, unlike permutations, the combinations of apple and pear and apple would be taken only as one. The formula for the number of possible combinations of R objects from a set of n objects is written as below. NCR is equals to factorial n upon factorial n minus r into factorial r. It is same as the permutations, but the only difference is that we take the sets with different orders but same value as 1. So we need to exclude that set, so we will divide it by r factorial. Now let us understand through a mathematical example. Suppose we have to find 52C5, where we have n equals to 52 and r equals to 5. Now in the denominator we will have n minus r factorial, that is 52 minus 5, which is equals to 47 factorial, and r factorial, that is 5 factorial. Now dividing which 47 factorial will get cancelled from the numerator, and we will be left with 52 into 51 into 50 into 49 into 48 in the numerator, and 5 factorial in the denominator, solving which we will be left with 2,598,960 as the result. Now in the logic for combinations, the only difference that would be created would be that we would in the function combination will divide by an extra r factorial, and hence which would result in calling the factorial function one extra time. As in the program, you can clearly see that we have just changed the formula in the combination function and changed the name of the functions and some variables. Rest of the program is the same. That's it. I hope you understood the program, and have left the link to the code of the program using functions as well as without functions in the description button. So make sure you check that out. If you have any problem or suggestion,